We are on page 156 if you're in the textbook. This is under the skill review. There is a table with the quadrants labeled. It's the one that is highlighted with the blue header row. And it's a table of the quadrants. So they've given us a section for each of the quadrants, and then they've given us some points that we need to plot, or not plot, but categorize. The first one is 1, -15. So in which quadrant would you find 1, -15? And I was thinking, can I graph these? I don't believe I can. So let me just talk you through it. This is over 1 and down 15. That is going to be in quadrant 4. It has a positive x and a negative y. 11, 2. Both are positive, so that is in quadrant 1. -10, 12. So back 10, up 12. That is quadrant 2. -1, +8. That is also quadrant 2. And I can't get it straight here. -1, +8. -20, -1. Back 20, down 1. Both coordinate pieces are negative, so that is in quadrant 3. And then +7, -18. That's going to be over 7 and down 18. So just to review, in quadrant 1, both the x and y are positive. In quadrant 2, quadrant 2, the x is negative and the y is positive. Quadrant 3, both are negative. In quadrant 4, the x is positive and the y is negative. I don't think you need to memorize that. If you can plot points on a coordinate grid, you're fine. That's just a different way of checking your understanding. Okay, number 2. It says to explain the relationship between the graph of a line and the solutions to the equation of the line. Use the graph shown as an example in your explanation. So let's duplicate the graph for those folks who do not have a textbook. The graph is on the full plane. So let me just go ahead and get in one of the colored graphs. There are times that I really need to be able to show you the quadrants. I'm not sure that this is one of them, but it could be. So let's go ahead and use this one. And I'll just delete this one out and paste this one in. So first of all, let's duplicate the graph that's in the textbook. And this goes with problem 2. They show us, really they don't show us points, but I'm going to have to draw points to get my line to snap. So they have origin, and then they have a point right here on the x-axis, and then they have a point right here on the y-axis. So they're showing us a line, and these are the intercepts of the line. It is positive. It's going in a positive direction. It is showing infinity on both ends. And so this is similar to the line that we're talking about. And it says to explain the relationship between the graph of a line and the solutions to the equation of the line. So the first thing I'm going to do is write an equation that corresponds to this line. So this is at point 1, 0. This is the x-intercept. And then this is at point 0, 1, negative 1. That's the y-intercept. So they've shown us 2 points on a line. Now, if I know 2 points, I can give you the equation after a little bit of work. The first thing that we want to do is calculate slope. Now, you could very easily look at this one and know the slope. If you can do that, that is fine. You don't need to go through this process. If you cannot do that, actually let me show you how to do it, and then we'll do the slope formula too. But remember, slope is rise over run. So we're looking at a rise of 1 and a run of 1. And then a rise of 1 and a run of 1. And then a rise of 1 and a run of 1. So you can see that the slope, just using rise over run, is going to be 1 to 1 or positive 1. And I think I'm just going to use that. I'm not going to do the slope formula. I am going to do slope-intercept formula. So let's draw the pattern that we want to use for our equation. You could use point slope, but I like slope-intercept if I can do that. So y equals mx plus b. Okay, y is going to stay in the equation. Slope is 1. X will stay in the equation. And what is baby b? At what point does it cross the y-axis? That is at negative 1. So baby b is right there. Can't really see it with it highlighted. It's right there. So negative 1 is that value of lowercase b. Now, when you simplify this, it's going to end up being, I always draw too much, don't I? Y equals, that will let the ghost 1 float away, so it will be x minus 1. Okay. That is the equation of the line. Now, they're asking us to graph or to explain the relationship between the graph of a line and the solutions. So let me draw a table of values. Let's make sure we know what the solutions are. Remember, this is where we use points on the graph to build the table. So x is 0, y is negative 1, x is 1, y is 0. So one thing we could say is that the solutions, and another way of saying the solutions would be to say the points, make the equation balance. And I'll show you what I mean by that. For example, when I say y equals x minus 1, I should be able to plug in my points and it should balance. So in the first one, y is negative 1 and x is 0. And this proves to be true. That's a balanced equation. Let's see if it works for the other point. Y is 0, x is 1, 0 equals 0, that also balances. So any of the points on the graph should fit in the equation and it should prove to be true. Another point we could make here is that the points allow us to calculate slope. You can do it with the slope formula using 2 points, or you can do it using rise over run if you have a graph. So that's another way that the points or the solution to the equation work with the graph. Now let me see what the answer key says. If you'll give me just a second, I will turn back here and see what it says. Here are some examples. The solutions of the equation are the ordered pairs that represent points on the line. Every solution is represented by a point on the line, and all points on the line represent solutions. So we're definitely bringing in the idea that the solutions are points on the line, and they will always make the equation balance. And let me just show you one more point here. I can tell you that right here, well, let's use this one way up here. This is over 5. Well, yes, that'll work. Over 5 up 4. So let's see if that is truly a solution to this equation. And to do that, you're just going to plug in the values. Over 5 up 4. And sure enough, that proves to be true. So any of the points on that line will satisfy the conditions of this equation. Again, I wouldn't fret about that question too much. It's more of a theory question, but it's definitely one that's good to think about. Okay, number 3, we have another graph that is across the entire coordinate system. So let me graph that one for those who don't have the book. We're going to put a point at -3, -1. So back 3, down 1. Back 3, down 1. And then we're going to put a point at 3, 2. So over 3, up 2. And we're going to connect those dots with a line. Now, they labeled other things. I'm not going to do that for the sake of time. Whoa, that wasn't very good, was it? My slope was off. Still off. Oh boy, this is going to take me a minute. Let's try this way. This is a very gentle slope. Oh, that's perfect. This is a very gentle slope. Okay. So let's see if we can figure out the slope using the points. Let's use rise over run and see what we come up with. So rise over run. It is positive. We can tell that just by looking at it. So here comes rise. From this point to that one, rise is 3. Run is 1, 2, 3, 4, 5, 6. And remember, I told you it's a very gentle slope. It is 3 units up, 6 units across. So 3 to 6, which will simplify down to 1/2. Slope is 1/2, or 0.5, and that is answer C, if you're following in the textbook. So number 3, the answer is C, 1/2. Okay, number 4, they have given us a table of values. So let's duplicate that. 5, I'm going to do it just like theirs, I guess, since. So 4 rows. First row is a header, and then we have 3 ordered pairs. So we have time in minutes, as our X value, and words read would be the Y value. And we have 2, 160, 4, 320, and 6, 480. And just for the sake of review, let's classify this is the independent variable. This is the dependent variable. And the question says, which describes the unit rate associated with the table? Now, remember what a unit rate looks like. A unit rate is the one that must have a top and a bottom. Now, I know that unit rate is synonymous with slope. It's also synonymous with that constant of proportionality, the K. So if I calculate slope, I'm going to get the unit rate. So let's do that. I'm going to use this point, this point and this point to do my slope. So let's label those with x1, x2, y1, y2, and let's do the formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that is going to be, I'm going to try to do this all as one fraction, but I don't think it's going to work. Let me try something here. Well, you could with parentheses. Okay, let me just do it the right way. 320 minus 160 is 160, and 4 minus 2 is 2. Now, we already knew that. Okay, and you might be thinking, why did you just do that when I already knew this to be true? 2 and 160. What we need is to reduce this fraction. That's what I was going to try to do on my calculator. But let's just do it mentally. 2 into itself would leave 1, and 2 into 160 is 80. So what this is telling me, if I put in another line here where 1 is x, 80 is y, this is the unit rate that we're looking for. 80 to 1. So what is that saying to me? It's saying that the person reads 80 words every minute. For a unit rate, you need a 1 in your denominator. Okay. Technically, you can have a 1 in the numerator or the denominator, but for our purposes here, we really want it to be in the denominator. So I could also say that slope, let's use letters, that slope is 80, and that the constant of proportionality is 80. And remember, with that constant, with the value k, it has to satisfy the 0, 0 rule. So if you have 0 minutes, you have 0 words. And that test does prove to be true. So we can say that slope and constant of proportionality are 80. The unit rate is 80 over 1. And the answer is A. The person reads 80 words per minute. Okay, number 5 says the table shows a proportional relationship between the time worked and money earned. Write the missing value in the table. So let's break this one down. 1, 2, 3, 4. I'm going to add a row. 1, 2, 3, 4, 5. Because something very important was stated in the problem in words. So let's bring this down right here. And we're saying that X is time in hours. That's the independent variable. And the dependent variable is money earned. That's the Y value. Now they tell me that this is a proportional relationship. So they're telling me that the 0-0 test was met. We can count on that. So this means that we can find a unit rate. And remember, a unit rate needs to have a fraction with a 1 on the bottom. That would be 1 hour. We can find slope, and because of the 0-0 test, we can find K. So here we go. We have a 1 and then an unknown, a 2 and a 21, and a 4 and a 42. Now, as long as I have 2 points, I can find slope, but we really don't even have to do that. Do I want to go? Let's do it both ways. Let me just go ahead and do slope down here. Slope is, let's use these 2 points. So we have x1 and x2, y1 and y2. And so y2, we're going to have 42 minus 21 and 4 minus 2 here. So we have 21 over 2. And hopefully you recognize I already knew that. So I didn't really have to go through this process. But since I have, let's go ahead and break it down. So 21 divided by 2 is going to be 10.5 to 1. And that is your unit rate. $10.50 per 1 hour. Slope is 10.5, and the constant of proportionality is 10.5. So all of those things are the same thing, provided the 0-0 test is met. And in this case it is, because they told us it's proportional. So in number 5, it says to write the missing value in the table. So our answer is right here. And I think I'm going to stop this video and then we'll get skills practice on the next one.